detection and diagnostics. So for an example, so this graph, just the top graph, shows the relationship between the engine RPM and the mass air flow. So this is essentially an oxygen sensor. So what happens is, as the sensor deteriorates, the gradient of that line decreases. So with that we can predict, okay, another 3 months or another 6 months, this is going to happen. Because the problem is, a sensor like this is a little bit expensive. If you could clean this up rather than really replacing it in advance, you could save a little bit of money. And then another example, we were given a data set about 4 months data of a bus that is running back and forth between Katubedda. It goes from Katubedda to Colombo Central Bus Stand, and then from there all the way up to Panama through Ratnapura and that area. So this one-way journey is about 375 kilometers. So we were given a full data set about this bus, the latitude, longitude, elevation on all of those, the speed, acceleration, all of that. Plus we had even high precision fuel sensors mounted into this bus. So we were asked questions like, can you explain the variability in this fuel consumption? Say for an example, if you look at this top left graph, that changes a lot. So the bus typically consumes about 90 liters one way, but some days it goes almost up to 180, almost double. So the question that the owners have is, why is this? Why is this happening? And then like, can you predict the consumption at the end of the journey? Because I want to know, this particular journey really took this much fuel. Not that the driver or the conductor managed to take a little bit of out and put, let's say, even, we have seen like even putting water instead of fuel. So what we did was we analyzed the data. This is a very simple descriptive analytics. We try to understand the variability. So we have things like, generally the outward journey consumes more fuel. Why? Because this bus leaves Colombo around 6 p.m. So because of that, you are into the traffic. This goes through the low level road. So up until like Avisavel, it experienced a lot of traffic. Then only the bus comes, go to Panama on the following day around 5 a.m. And then again we see like very basic things like, as we get close to the weekend, more people tend to travel on the bus. So the fuel consumption naturally increases. And this bus has like a sweet spot around 50 kilometers per hour. The fuel consumption is optimum. So going beyond that doesn't really help. And we also see like significant idling by the driver as well. So what we did was we took this, we did a little bit of data cleaning, and we tried various algorithms to see whether we can predict. So these are 3 results, and the top left, the red ones are the actual consumptions, the blue ones are the predictions. So we were able to predict up to about 90% accuracy. So given a certain day, how you go on a certain route, this particular route, and we could say this journey should have consumed this much fuel. So then we can compare with the actual one. In this case, we see a difference of only about 7 liters. So then this is another system that we are currently deploying in Sri Lanka. This is called Center for Urban Water. So this is for flood control as well as forecasting in Colombo, primarily targeting Colombo. So we have set up weather stations. Some are imported. These are just what we can buy from eBay. Plus, some of these are developed in Sri Lanka by several companies. And we have a couple of even water level gauges. So what we do with this system is, we want to collect as much as data. We also get the satellite information. We do our own weather prediction. Based on that, we could tell on the Calendar River, given the certain amount of rain, how much will be the water level. Based on that, who would be affected. So we have a simple interface that currently we have 9 weather stations connected to this system. So we have real-time information coming from all of those. So what we see on the other side is the individual parameters from one of these stations. So we are actually looking at a public-private partnership plus even a crowdsourced model. So 2 of these weather stations are actually not owned by us. These are just 2 people. They have their one set up at the on their top of the roof, and they're just collecting and giving us the data in real time. So what we do really is, in this case, we collect the data primarily from satellites, and then we collect also from these weather stations water level gauges. So we are looking at the river levels and things like that. Plus we also have pumping stations. So actually current couple of pumping stations are being built because one of the biggest problems in Colombo is the gravity cannot really take the water out, because the change in topography is so little. If you get a lot of rain, within a short period of time, there's no way that we can let it out to the sea. So only option today is to pump. So we are, with this system, what we are really looking at is when do we need to pump, from where we need to pump, and decisions like that. So ideally what we want to do is we want to have this integrated system feeding us data. This is entirely on cloud. So no servers with us. We run entirely this thing on the cloud. We can actually currently predict and give warnings, but we don't directly give warnings. We give that to the disaster management center. Plus we have a lot of GIS data about the buildings around the Kalani Basin. So we know exactly what type of a building is this, how tall, how many people are living, and if this place gets flooded, how many people will get affected. Because our objective would be to say, if you are an insurance company, say this area is going to get flooded up to 2 meters. So you may go back and tell your customers, send an SMS and say, there is a warning, you better move your vehicle out. Maybe in whatever the damages, we may be able to give you a better discount because if you honor whatever we are saying to you. So what you are looking at is a platform that essentially integrates all of this. And currently we have 9 stations. We want to go to into 100 because Sri Lanka currently have more than 500 weather stations owned by various parties. So kind of motivating them to connect to a similar same system is kind of becoming difficult. But we hope with a lot of crowdsourcing we can do this. And there will be more water gauges because there is actually an plan to have the canal based transportation system. Say for an example, you should be able to go from somewhere close to the parliament all the way up to the Vellavatha just using the canals. So with such a system, the water level measurements are extremely important. So we are looking at that aspects as well. So now the question is, if you have something like this, what can go wrong? Because it's nice, we can collect a lot of data, we can tell what is going to happen, we can save lives and all of those, but unfortunately things can go wrong as well. So we have to plan for that. So some of the examples would be, let's say someone tampering our devices, or even the drivers in the GPS case. If you are tracking, the drivers tend to do whole sort of things to somehow disable this device. So then again, unauthorized control, let's say someone start up a pump, we'll be in trouble. So we don't want that to happen, though we are controlling these pumps over the, we are actually having both wired as well as wireless, just to be sure, because if one fails, hopefully the other one is there. And then we don't want modifications or even denial of service attacks and things like that. But on the other hand, if you look at the privacy, so one of the biggest concerns drivers have, particularly when it comes to monitoring, is like, could this be used against me if I have an accident? So we have even done a study with a lot of about 300, 400 drivers in Sri Lanka. So all of those wants to try this idea of usage-based insurance. But when it comes to this particular question, this is the only question that they disagree. They would worry that my insurer would use this data against me. So not just my premium will go down if I am a good driver, but there is definitely a chance that your premium could go up a little bit, not a lot, if you are a fairly bad driver as well. So then again, we have a lot of socio-economic data, particularly with the buildings, who lives there and few other things. So we don't want that sort of a data to be exposed as well. So here's an attack that happens in 2016 October. So this is the very famous Dyn attack initiated by a malware called Mirai. So Mirai is actually in Japanese means the future. So this whole attack was proposed to demonstrate the power of IoT in the future, but actually the disruptive power of IoT. So what happened was about 10 million devices, primarily in East Asia and parts of Europe, were attacking these DNS servers by issuing so many DNS queries to the Dyn DNS servers, which were primarily serving the US market. So all these websites were up and running. It was just people were not able to say, let's say when you say google.com, that domain name never resolves to an IP address because the DNS servers were busy dealing with these so many requests. So interestingly, this is a very simple attack. Just run an IP scan. You just randomly try some IP address. And if you find an IP address, you try a known set of username password combinations. So all of our wireless access routers, DVRs and all of those typically comes with a default password, something like ABC123 or admin. So they tried this table and they were successful in reaching 10 million devices. So then what they do is they log in through Telnet So these were essentially Linux devices running telnet, whereas if you are running a Linux desktop or a laptop or even a server, you would immediately disable telnet. This actually comes disabled by default, whereas not on these devices, unfortunately. So they download the malware, and this malware was just waiting for a command on a certain day, certain time. They said, just go and ask 9 about various domain names. So this is what they were really doing and really disrupt the whole ecosystem. Now then, getting into a little bit more details about what kind of attacks are possible. So there is this OAuPS top 10 list. So OAuPS is a non-profit group that do conduct surveys that talk to a lot of professionals all over the world and come up with this 10 list. So they have something called the OAuPS, Open Web Application Security Project, top 10 for web applications. Similarly, they have another top 10 for mobile, and this is the IoT one. So this came up in 2014, and a new version is expected this year. So I'm not really going to go into details, but if you look at some of these we already know. So for an example, so most of these devices have some sort of a web-based interface. So that interface could be used to initiate so many attacks that we don't think of, not just even SQL injection, more complex ones like cross-site scripting and session hijacking and things like that. And then most of these you cannot do very complicated authentication. They would just accept a username and a password, and even the password cannot be very long, or maybe you can only have uppercase, lowercase and a digits. That's pretty much it, not much detail. So then they don't necessarily encrypt most of the traffic. So this leads to a lot of issues, and most of the time these devices store the data on whatever the flash ROM or SD card that you have unencrypted. So this leads to so many issues, and again the very bottom one, the physical security. So we hardly assume this will be a problem because we go and deploy somewhere, hopefully no one would touch, whereas this becomes a huge problem if someone really, let's say, use the USB port or the DHCP port to see what is in, or just say, let's say, take the device, go home, just to see what is happening inside this device. So when it comes to protecting these devices, we could look at, or the whole application ecosystem, the IoT application ecosystem, we could look at the solutions at 3 levels. We can look at the device security, so which I think was discussed even in the previous presentation. And then we could talk about even how we protect the network. Then again, this was discussed as well. Then because we collect so much data and process them, we need to also worry about how we protect that aspects as well, whatever we store as well as collect. So if I'm to give you like 10 things, very, very basic things to focus on when it comes to protecting your devices. So the most important fundamental should be collect what you want. Not that I may need this data someday, let me collect as much as I can. Hopefully we can build some application someday. That is not a very good approach. So collect the bare minimum that you really need, and if you want to do these things in the future, you should have a device that you can upgrade in the future. Not that you have a device that you can put the code only once and that is there until it dies. So better option would be figure out what you really need and start with the simple things. Later let the device maybe even upgrade over the air rather than really physically going towards the device. So then we need no defaults at all. All the default usernames, passwords, ports, the services, all of those need to be blocked. And then digital certificates are must. It's actually a very, very difficult challenge dealing with the SIMs, the authentication, the key sharing and all of those. And as the number of devices get increased, this becomes actually a nightmare. So for an example, even with the 9 weather stations that we have enough problems. The SIM management, suddenly some SIMs does not work, we have to send someone, and not just that, someone has to climb to a roof to fix this. So it becomes a huge headache as well. So that is where a platform that supports these things would be very much useful. So then things like role-based access control, and we need to use devices that can store encrypted data. So not an SD card. Never put it in an SD card because someone doesn't need to take your device, they just need to take your SD card. So idea would be the physically to build this, and then again, like whatever the web interfaces that you have, they need to be protected, they need to be secure, and again use hardware level encryption because most of these devices come with AES. So for an example, NB-IoT come with even 2048 bit RSA. So use the hardware because it's cheaper, faster, and more importantly saves your power. Whereas if you try to do the same encryption in software, it's going to consume more power. So then again, like disable USB ports, JTAG ports and all of those. and depending on the application also use rugged devices as well. Now, this is what you need to look at. Let's say you are going to choose between device A versus device B. See which one satisfy most of these, and then see which one would fit in your application based on most of these, plus definitely you need to consider about the cost. But in at least having the first 5 is not very difficult in most of the devices today. Then when it comes to network, again the basic things like VPNs, VLANs, SSL and all of those. So every form of communication, whether it's plain text, MQTT or REST APIs, they need to be encrypted. So use TSL, not SSL anymore. SSL is no longer considered to be secure. So use TSL either version 1 or 1.2. And then use the underlying network which is secure. So for an example, NB-IoT or LTE-M, those are considered to be more secure compared to some of the other competitors. So if you are using Wi-Fi, it has to be with WPA2. And Bluetooth try to avoid, whereas then things like ZigBee and few other proprietary ones are somewhere in between. They are not so good, but they are not so bad as well. And other thing is, don't rely only on the network level security. It's again another recommendation would be whatever that goes out from my device all the way up to whatever the cloud that we have should also use application level encryption as well. Another thing is, we see this many a times when we do code reviews. People just implement their own algorithms. There are well-known algorithms that are known to be secure, and there are well-known ways of implementing this, but for some reason, people develop, unfortunately, their own algorithms, so which is not recommended. Then if you look at the data level or the processing level, so again, we need to collect and process only what is essential. So again, no defaults, because you may have various machine learning libraries that may help you to process your data. Again, be careful. So again, role-based access control, accounts should lock out. So not that, let's say if someone try 5 times, still fails, you should lock out. So this was a mistake that in the Dyn case happened, because these devices were allowing them to pretty much try all that 60 username password combinations. So not that it was blocked, let's say after 3 or 5 combinations. They were just essentially doing a brute force. So then digital certificates need to be used, and you need to ensure the communication, whether it's REST or MQTT or something else, and more importantly also get your certificate from a reliable party, not the default certificates. So for an example, particularly if you develop Android apps, you are very much likely to go with the default Android certificate. Don't go with that, it's not recommended. So and also don't use self-signed certificates. Go with something that is more acceptable. And then again, we need to protect all our APIs, various forms of interfaces for attacks, again like things like SQL injection, cross-site scripting, cross-site request forgery. Some of these attacks are a little bit complicated. And the other thing is use strong API keys. So many a times we see APIs being used but not encrypted or not used with a larger key. So other thing is you need to protect your keys. So it's not just you give some party a key saying, okay, you can use this key to talk to me, but you have to really protect them, because anyone else could really talk using those. And then again, encrypted storage, even at the server level, that is extremely important, because we have cases where clients come and even ask, like, okay, when you keep this in the cloud, how do you keep it? Is it secure? Is it encrypted? And what we see is sometimes even clients says, can you make sure you cannot open up this data without us giving you a key? So this is a little bit different, because we have been putting these to a storage and encrypting by ourselves, by where we know the key. But now it's like client is coming up with a key and saying, okay, you need my key as well as your key to open this up. So that kind of solutions are also being looked at by clients. So other thing is use standard authentication techniques like OAuth2, not just some random ones. And the other most important thing is to be know whatever the libraries you are using, because about 70% of the web applications that you realize there is an attack, they are primarily because of some third-party component that you downloaded from somewhere, because those were vulnerable, not really your application was vulnerable. So to summarize, so collection of data is a functional requirement, so we cannot say no. Whereas security and privacy is a non-functional requirement. So the choice is very clear. When these are in conflicts, we would go with the functional requirement of collecting as much as data that we can, rather than really worrying about how are we going to protect them or what are the implications if we don't protect them. Then another thing would be, if you are a developer or if you are an architect who would be designing solution like this, remember that you will be hacked one day. So don't think like I may be hacked or I could be hacked and then hope that that is not going to happen to me. It's going to happen to you someday or another. On the other hand, people are realizing that we need to be worried. Say for an example, a survey conducted last year in US, about 62% of the participants said, in IoT my biggest concern is privacy. And today there is a huge movement saying people sign out from Facebook because of this recent incident where 50 million accounts were compromised. So users are now starting to think, so in that domain or in this competitive market, if you don't have a product, it may be very much feature rich, but unfortunately it is also security as well as privacy issues. It consists of so many such issues. You are asking for a real killer. That could essentially kill your whole business. So what I would suggest is, you need to think of a good balance, not just in design, development as well as deployment and even beyond that. So later maybe you could add certain features, but all the time like think about this 3-step process. Let's design secure, let's build secure, as well as let's deploy secure. So in this process, like if you really want to take something out, every developer, every designer, I would say today, need to know at least OAuth top 10 for the web, mobile and IoT. Because all three are very much connected in this domain. We have a REST API which is web. We have mobile devices that shows various things about our IoT products, what they do, what they can collect, the predictions and all of those. So because of that, it's very much important to at least know. These 10 actually not very difficult. Those are fairly simple ones. It just